All right, let's get right after it. SAT 2021 April calculator. This is the official test. And let's get started. What percentage of 40 is 15? So a couple different ways we could do it. It's basically saying what is 15 out of 40. All right, and if you do that, you could just divide it in your calculator. You could also reduce this fraction down. So if I reduce this down, 5 goes into here 3 times, 5 goes into here 8 times. I know that 3/8 is 0.375, which when you want to change a decimal to a percent, you can move it 2 places. So 37.5%. Correct answer will be B. Some people set it up. They do this is over of percent over 100. Then you don't have to worry about moving the decimal. So your is 15. Your out of is 40. We don't know the percent. We do know the 100. And you could also cross multiply and set up an algebra equation. And if you carry it out, you will get 37.5. And you don't have to worry about moving the decimal at all. So a couple different ways you could do that one. Moving on down to number 2. So this one says Shelley spent $235 to rent a moving van. Equation shows the relationship. D is the days that you rent it. M is the miles. So M is miles. D are days. Makes sense. She rented the van for 3 days. So we actually know the days. So we know that D equals 3. And we need to find how many miles. So we need to find M. So I go up to my equation up above and I rewrite it. But instead of 20D, I know that we're doing 3 days. I don't know the M. So this is basically just solving a linear equation. It's actually called interpreting a model because they're giving me a model for this thing. But let's just do it. 60 plus 0.7M equals 235. I'm going to subtract 60 from both sides. And I get 0.7M equals 175. Divide by 0.7, divide by 0.7. And that's going to give me, what do we have? M equals, looks like 250. So M equals 250. All right, moving right along. Next question. Looks like we have a system of equations, but it's really nice because one of them are already solved for me. So if you struggle with systems, you could go see one of the topic videos on systems of equations. Most of them are elimination, but this one, they flat out tell me what x is. So I'm going to actually use substitution. So I'm going to substitute that 3 right in here for the x. And I get y equals 3 plus 3. So y equals 6. So they told me x equaled 3. I found out that y equals 6. So I now have an ordered pair. Remember, it goes x comma y. So the correct answer here is A. All right, let's go to the next one. Looks like we have a function. It's modeling temperature. So let's just jump in. F of x is the temperature in Fahrenheit in Chicago X days after November 1st. So it looks like they kept track of 29 days that month. Based on this model, what is the average daily temperature in Chicago 6 days after November 1st? All right, so X is the number of days after the 1st. So I need to put a 6 in for my X. So when I put a 6 in there, I get negative 0.5 times 6 days plus 56. Well, half of 6 is, that'd be negative 3 plus 56, or 53 degrees. So the correct answer here is D. All right, next question. Looks like I'm going to have to shrink this one down a little bit so we can see our graphs. And maybe I'll just copy that table. Well, one thing I noticed just looking at the table, because I'm supposed to match up which one of those graphs match the table. Well, remember, this is just X and Y. So I have 3 zeros here So y is 0 3 times. You know, those are basically x-intercepts. It's kind of telling me that I cross the x-axis at -2, -1, and 1. Because at all those spots, y is 0. Well, this one crosses, it's not y equals 0 at the right places. That would be at -2, 0, and 1. So that one's out. B only is y equals 0 in 2 places, not 3. So it can't be B. So I'm looking at -2, -1, and 0. -2, -1, and 0. Looks like right here. -2, oh no. -1 and +1. Those were the 3 spots up on that graph up above. It was -2, 0. It was -1, 0. And then it skipped down to 1, 0. So that one matches up. So the correct answer here is going to be C. All right. Next one. Number 6. The volume of some magnet is 2.5 cubic centimeters. The mass is 18.5. What is the density? So this is a science equation. This is coming up more and more lately. It wasn't really on the older ones a lot. But there's a relationship between those, and they don't give it to you on the front of the test. So you have to know from science that the density is the mass of the object divided by its volume. So I kind of need to know that science equation. So when I put the numbers that we have in, we know the volume is 2.5. And I know the mass is 18.5. So to get the density, I just have to divide those two out. And when I divide those two out, I end up getting 7.40. Almost don't need a calculator for that one. You can just kind of ballpark it, and the answers are pretty far away. All right, next problem, number 7. An automobile uses 27 pints of fuel for every 63 miles traveled. So this is a rate question. So whenever I'm doing rates, I usually set up a proportion, which might be different than sometimes in science class how they do it, but I like to set it up as a proportion. So I'm using 22 pints of fuel for every 63 miles traveled. And I might even off to the side just put pints and put miles, because I know when I set up my equivalent rate, I have to put pints on top and miles on the bottom. So I have to be careful. So it says how many pints, so I don't know that for 7 miles. You could cross multiply and then divide, so some people might do 27 times 7 equals 63x and solve that. But to me, I can see that this is basically just dividing by 9. So I know to keep the ratio the same, if I divide by 9, I'll get an answer of 3. So the correct answer here is D. Next question. So number 8. So this is another one. This is a conversion problem. How many fluid ounces are equivalent to 40 cups of a liquid? That's what happens when you grab tests off the internet. It's missing stuff. So I use this as a rate. I know that 8 ounces is 1 cup. So 8 ounces is 1 cup. So 40 cups would be how many ounces? So on this one, you can just cross multiply, and you get x equals 320. Correct answer, D. All right, next question. Number 9. Let's see what we got here. Looks like 9 and 10 are both from the same picture. Shrink this down just a tad. We got 6/7 is that last choice down there, so I'll just kind of add that on the side. 6/7 is D. All right, D is 6/7. All right, well, when I look through here, it says for a sample of 12 alder trees, so that's what those dots are. At a height, an arborist measured each tree's diameter at a height, certain height. They then counted the number of growth rings. Each point in the scatter plot represents the diameter and the number of rings. So a red alder tree will be selected at random from the sample. what's the chance that it's going to have a diameter greater than 30? Well, when I look up here at my chart, greater than 30, that represents pretty much all the dots from, so it would be 1, 2, 3, 4, 5, 6, 7 dots are to the right of this line. 7 dots are greater than 30. So I know it's going to be 7 out of, and there were 13 in our sample. So 7/13. So it looks like the correct answer would be C here. 7/13. All right, next question. Scrolling down, same scenario. See what they asked this time. For how many of the trees in the sample is the number of rings greater than the number predicted? So they come up with this line that predicts like where the rings are going to be based on the diameter. And all the dots above the line were greater than expected. So it looks like I have 1, 2, 3, 4, 5, 6. So there are 6 dots there that are clearly above the line. There's a couple on the line, so that would be exactly what was predicted. But we have 6 that were greater than what was predicted by the line. All right, next question, number 11. So this looks like some sort of a scatter plot. And the scatter plot shows 10 values from the data set. Which of the following is the most appropriate linear model for the data shown? Well, I'm just going to generically draw some line in here that looks pretty close. So, I don't know, maybe something like this. That's a line that looks somewhat close. And a couple things I know about the line. I know that it has a positive slope. All right, and remember, slope is y equals mx plus b. So you have this number that is in front of the x. That's the slope. So I need a number in front of x to be positive. So that wipes out choice B. The other ones look pretty good. I don't really like these two because they both have a y-intercept of 0. And I don't know, that looks kind of low to me. But maybe I ought to check the slope just to see what's going on. So I'm going to pick a couple points. Like I put somewhere from like 5 over here to 90. Well, the slope is the rise over the run. So the rise, and I'm just kind of ballparking here, the rise would be 35. And the run would be 90. So 35 over 90 is somewhere around a third, somewhere in that neighborhood. It definitely is not, this is greater than 1. It's definitely not greater than 1. Up 3 over 8. I don't know. I think this 35 over 90 is a little bit closer looking to me at 3/10 than it is 3/8. So I'm going to go with answer choice A. Plus it also kind of, I knew that this y-intercept I thought was greater than 0 looking at the picture. So if I kind of work backwards, maybe I'm unsure about this and I want to go back and double check it. Maybe I just graph it and I'm like, well, what happens if we start at 9 and then we go up 3 over 10, because that's what 3/10 tells me to do. And so maybe I'll go up 3 over 10, and maybe instead of going just 3 and 10, well, I could do it. Up 3 over 10 would put me at 12. Up 3 over 10 would put me at 15. It put me at 18. It would put me at 21. Put me at 24, 27, 30. No, 27 would be here. 30, 33. I think that looks pretty legit. I think that's a pretty good line. So I'm going to go with it. I think the other one, like if I was like, well, what about this guy right here? If I kind of thought about him, if I started here and went up 3 over 8 to speed this process up, instead of up 3 over 8, I could just multiply it by 10 and go up 30 over 80, which would put me like right here. And I don't know, that doesn't look like a very good line of best fit. Because if you compare that, there's a lot of dots way above that line, only one below it. So I don't like D as a choice, so I'm going to go with A. All right, moving right along. Number 12, looks like we have a geometry problem here. So it says triangles ABCDF have a corresponding angle of 40 degrees. So let me just try to kind of draw one with a 40 degrees. What additional piece is sufficient to determine whether they are similar? So first of all, remember what similar is. Similar means same shape, but different sizes. So like one is a big brother of the other one. So maybe you have like, kind of this thing going on. Well, right now I know that I have two angles that are both 40. And in geometry, we kind of show them with a congruence mark like that. Well, in order to prove two triangles are similar like that, if I could get another angle, if you could lock down another angle for me and maybe be like, hey, this angle's 30 and this angle's 30, if I could get that, that would for sure lock it in, because since they both have to add up to 180, that would leave me a 110 and a 110. So basically, as long as I have two angles, I can show that they're similar. So I would need C, another pair of corresponding angles. All right, number 13. This one looks kind of weird, but I don't think it's too bad, like once you actually start getting into it. So they want you to waste time, and they want you to distribute all the way through. And then you're going to find a value for x, and then you're going to have to come over here, and then you're going to have to put that x back in. That's a huge waste of time, because if I notice, this big old thing in parentheses is basically what I'm trying to find. So kind of think of it like this. Think of it as like 3 times this big old box of I don't know what, added to 1 equals 10, and just treat it like an algebra problem. If 3 times something plus 1 is 10, to solve that, you minus 1 from both sides, and I get 3 times something equals 9, and then divide both sides by 3, and I'm like, oh, that big old box of something equals 3. And that's all they want. They don't need to know what x equals. So that whole expression there must just be equal 3. So kind of think about it as structure, or you could even think of this big old box as an x, and this big old box as an x, or maybe a y, if it's confusing, but I think that'd be an easier way to do this. All right, number 14. It's like we have a exponential decay problem here, exponential decrease. But what do we need from it? For the graph of the exponential function is shown, for what value of x is f of x equal to 0? Well, remember, f of x is really just y, our output. So when is y equal to 0? Well, y is equal to 0 right here, because at that ordered pair, x is -2, the y value is 0. So it looks like for what value of x, -2 is the value of x. That gives me a 0 there. Now they probably want you to screw this up, and they want you to put 0 in for x, which would be this question. If they says what was f of 0, then that means you put a 0 in for x, and you try to figure out what y is. Well, that would be a -3. So that's a bad answer, but they put it right here. They want to trick you, but don't do that. That's not what they were asking. So be careful. All right, number 15. We have a set of numbers. The given list shows the baseball team score for their first 10 games. In the 11th game, they had a score of 18. So, man, they blew somebody out. 18 runs in that game. Which of the following best describes the mean and the median for the first 11 games compared to the first 10? All right, here's the thing to know. When you add a really big number to a set of data, you are going to increase the average, aka the mean. The mean is going to go up because now you're going to add 18 to it and you're going to divide by 11, and that 18 is way bigger than everybody else. So you're going to increase the average. However, the median, let's just take a look. If these 10 numbers here, the median is right in the middle. So the median would be at the halfway point, which is actually tied between those two 5s. So the median was 5. But even when I add in this next number, and I now have 11 numbers, there's an exact middle. It's going to be the 6th term. It's going to be right there. So the median is still a 5. So basically what happened was we increased our average, but our median stayed the same. That happens on so many of these problems that I see. So that's just kind of a common thread. If you put a really tiny number in, your mean is going to decrease, but your median is often going to stay the same. Not always, but I would say 9 out of 10 times when I see these type of questions, they just want you to understand that one can change, but the other one doesn't. All right, so let's give this next one a shot. Make it a little bit bigger here where we can see. So I have a quadratic. Whenever it has a 2 there, and that's the biggest term, it's called a quadratic. Says, which of the following could be a value of x plus 3? So they don't want me to know what x is. They want me to know what x plus 3 is. So I may have to find out what x is and then plug it back in. Well, normally when I try to solve a quadratic, you have some options. Always, 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 to solve a quadratic, aka an x squared problem, I always try to factor, almost always. You can always use the quadratic formula, which is big and nasty, and I think it comes up later on the test, but I would never use it if I don't need to. And sometimes you can get lucky enough by just taking the square root of both sides. That usually you can do if you don't have the x term, but since I have this x term, I can't take the square root of both sides. So let's try to factor it. So x squared plus 2x minus 3 equals 0. Well, when I factor it, remember I'm trying to play the game where I want to find two numbers that can multiply to make a negative 3. Well, really my only options are positive 1 and negative 3 or negative 1 and positive 3. Those are my only choices. But then out of those numbers, I got to be able to add to make a positive 2. So it looks like this is my choice. X minus 1 times x plus 3, and it equals 0. So now I'm going to use what's called the zero product property, meaning that if something times something equals 0, one of those two are 0. Either x minus 1 is 0 or x plus 3 has to be 0. Now usually I would solve these, but on this problem it says, what is the value of x plus 3? Well, I know x plus 3 has to be equal to 0. Now if I wanted to go further, I could solve this and say, well, x equals 1 is an answer, and x equals negative 3 is an answer. So if I put 1 in here, it could have been 4, but I don't see any choices of 4 over here to the left. So I didn't need to do that. But if I put the negative 3 one in there, I do get the 0 right here. So, but you didn't have to go that far. All right, number 17. Shrink her down a little bit. So it looks like we have a survey. I see the word probability in there, so statistics type problem. The biggest thing with probability is you need to figure out how many it's out of. This is usually who the sample is. You have some sort of random sample, and you need to know who are your choices on the bottom. And then your top is just kind of your target people. So you really want to kind of, the big thing I always try to find first is who is it out of? So it says the table shows the results of 1,000 people. Respondents were asked to agree or disagree with the statement, I rely too much on my phone. If a respondent who is selected at random disagrees with the statement, so that's important right there. So it says a respondent who was selected at random disagreed with the statement. So out of all the people that disagreed, those are the only choices that are in the hat. Those are the only names we're picking randomly from. So if a person selected at random disagrees, what's the closest to the chance that they are at least 45 years old? Well, at least 45 means 45 or over. So on the chart, the 45 and up people would be these people right here. All right? Because we're only looking at people that disagreed. So that would be 303 people out of the 548. And when you divide that out with your calculator, it comes out to be, the answer is D. All right, so be careful. A lot of people would accidentally divide by 1,000. You don't want to do that, so just watch out. Number 18. Let's see what we got here. Table above shows several values of x and their corresponding values of y, where k is a non-zero number. The relationship is linear, so that's important. So basically we have a table, and normally if I have a problem like this, I just do the change in y and the change in x to find the slope. This one is kind of weird though. Like I've never really seen one like this on here before. But so slope is the change in y over the change in x. Well, the change in y values, maybe I'll just go from here to here. If we go up from 0 to 2k plus 2 for every 1, so there's my slope. So my slope is 2k plus 2. So remember, y equals mx plus b. So I know what my slope is. It's 2k plus 2 times x. Well, my y-intercept, it looks like the y-intercept is 0. Because remember, the y-intercept is when x equals 0, that's the y-intercept. So it's 0, 0. So that means there's no number at the back side here. So here's my equation. I don't really see that over there. So I'm going to distribute this x through here. So I get 2kx plus 2x equals y. Well, I know it's not this negative 2k. I know it's not that. I don't have a 2 in there. It looks like what they did was, in my final answer, they factored out a 2x and just kind of put in here, kind of do like the reverse distributive property to get that, but I don't like this question, but the correct answer is A. All right, number 19, see what we have here. Half-life of, well, right there, when you tell me half-life, I know this is exponential decay because something's getting smaller and smaller over time. And it says, at the end of every 8-day interval, only half of the amount was left, which the following best describes over time. So it's not linear. Remember, linear means constant change. And this is not constant change because it gets cut in half. So for instance, if you start with 100 and you get cut in half, and you get cut in half, and you get cut in half, like if this was like x and y, it's not constant change. It's changing by a different amount, every single time. This one dropped by 50, this one dropped by 25, this one dropped by 12.5. That's not linear. And it's not growing or increasing. So the correct answer here is D. Number 20. All right, this says an xy plane, a circle with a radius 2 has a center at 0, 0. What is the equation of a circle? Well, the equation of a circle centered at 0, 0 is in the form x squared plus y squared equals r squared. All right. So for instance, if we want to have a radius of 2, that would be x squared plus y squared equals 2 squared or 4. So the correct answer here is B. So that was just knowing the equation of a circle. They always start off this way if they're centered at 0, 0, and then you change the radius. If you want to move it left, right, up, down for your center, you have to make some adjustments, but not for this one. Number 21, what do we have going on here? The total cost in dollars to tile a square floor is represented by C equals 16 L squared. So C equals 16 times L squared, and C is the cost, and L is the length of one side of the floor. So if you have a room, and one side of the floor is L, and the other side of the floor is L, the area is going to be L squared. So this is the area of the room. So which defining represents the cost in dollars per square foot? Well, it looks like if L was 1, that'd be a pretty small room, but it'd be 16 times 1, it'd be $16. You know, if L was 100, or if L was, let's say, 10, and my room was 10 by 10, that would be 100 square foot times by 16. That'd be $1,600. So it looks like this 16 is the cost per square foot. Dollars per square foot, $16 a square foot. Kind of an awkwardly worded question, but the math wasn't too horrible. So what do we have here? Object A has a mass of X. Object B, all right, so we have A, B, we have a mass of X, and we have a mass of 1.1 times X. What is the ratio for A to B? So the ratio of A to B. Well, it's not 1 to 1, because that would mean they're the exact same. It's not 1 to 11, because that means one is 11 times bigger. This one, A, is not 10 times bigger. I think it'd be D, you know, because if I put a 10 in here, and then I put a 10 here, it would be 10 to 11. All right, so the correct answer here would be D. You can scale up ratios like that to make them match the answers that they have on here. Number 23, looks like we have a geometry problem. The volume of a right triangular prism. Well, the volume of any prism, the volume is always the base area times the height of the prism. Now for this particular shape, the base area is this triangle right here. You know, that's the base area. So we have this triangle area times the height, which we know what the height is. Looks like the height is 12. So it says the volume of a prism is 96. So they tell me that 96 is the volume. So 96 is the base area times 12. And they want to know what's the base. So this is just a division problem. Just divide by 12, divide by 12. It looks like that blue base area is going to equal 8. So the correct answer here is B. Number 24 looks like another statistics problem. See the word standard deviation in there. The dot plot shows the distribution of heights of members of 4 basketball teams, A, B, C, D. Of the data set summarized, which has the smallest standard deviation? Well, standard deviation is really the spread of the data. Anytime I've seen this question asked on the SAT, it just wants you to know how tightly clustered things are. So when the dots are really spread out, they have a big standard deviation. When the dots are mainly really tight, you're going to have a small. So when I look at this data set, look at all these dots that are clustered. Most of the data is right in here. So this is going to have the smallest standard deviation of all of these. The other dots are spread out. They're kind of equally distributed a little bit more. But these ones are all clustered really close together. So the correct answer here is going to be D. Number 25, what do we got going on? Sanjay works as a teacher's assistant for $20 per hour, tutors for $25. Last week he made at least $100. So X hours is the teacher assistant. So the teacher assistant is X, and Y is the tutor. So Y is the tutor. And now we got to get this money in here. So you get $20 times every teacher assistant hour, and you get $25 times every tutor hour. And then we have this word at least. So if he made at least, or she, I don't know who that is, but at least $100. Well, I'm looking down there and I don't see my answers, but it looks like they divided through. So if I try to find a greatest common factor for all these numbers, I think I can use a GCF of 5 and just divide everybody by 5. So that'd be 4x plus 5y greater than or equal to 20. So correct answer here is B. All right, number 26. Let's see what we got going for 26. Psychologist conducting a memory experiment provided participants with a list of 3-letter sequences. Immediately after, people could remember 100% of it. But then they found that that percentage decreased by 30%. All right, so I want to highlight that. We decreased by 30% for every 3-second interval. So every time 3 seconds went by, we lost 30% of our memory there. Which function best models the situation where p is the percentage, t is time in seconds? All right, well, for all of these type of equations, you always have the initial value. All right, that's going to come first. And not an equal sign. Then you're going to multiply that by, it's either 1 plus r or 1 minus r, whether you are going to increase or whether you're going to decrease. We're decreasing 30%. So 1 means I wouldn't change. If I multiplied something by 1, I would keep the same thing. But I'm going to decrease by 30%. And then we usually have some sort of a time component up here. So we usually have some sort of a t. I'm going to loosely put that because I see on this problem, there's a couple answers here that both have a little something going on. So our initial value of people, or our percentage was, we were at 100. And this would be 0.70. So I know right away these two answers are not right because they didn't do the 1 minus part. But now I have to make a decision. Which one of these is it? Is it t over 3? Or is it just plain old t? All right, that's my decision. Well, let's kind of dig in a little deeper. And that's where this 3-second interval comes in. I don't decrease 30% until after 3 seconds. All right? So, when t equals 3 seconds, that's when I get my first decrease. So I'm going to want to choose this one because when I put my t of 3 seconds in, that really comes out to just be 1. So it really comes out to I've only lost 30% one time, but it took 3 seconds to get there. If I were to choose the other one, if I would have chose this one, this would be like the next best wrong answer. But if you put a 3 in here, that means you're actually going to decrease 30% 3 times. That would be starting with 100 and then doing this. And that's not really what's happening. We didn't decrease 3 times. We only decreased 1 time in 3 seconds. So correct answer here is going to be C. It's a little bit tougher though. Number 27, shrink this down just a tad, move it up. So the given above models 3 credit hour courses, 4 credit hour courses that Camilla can take for 16. Which graph models a relationship? The easiest way to do this is to, whenever I see the x and the y on the same side, this is called standard form for a line. Standard form. And I almost always pick some intercepts. I either let x equal 0 or y equal 0. So if I let x equal 0, basically this part goes away because 3 times 0 is 0. And I get an answer of 4. So I know that's a point on the graph. 0, 4 has to live on this graph. So I see a 0, 4, so you're okay. Nope, you're not on the graph. Nope, you're not on the graph. Nope, you're not on the graph. And I'm done. Let's say that there were 2 of them that were on the graph. Then I would kind of want to go back and I would want to find the other intercept. So I would let y equal 0, which would make this disappear. And then x would be like, I don't know, for this problem it's kind of weird, but it would be 5 1/3. So then I would be looking for, 5 1/3, 0, as my other choice. And if you notice, right there it is. That's the 5 1/3. So I like to always use this little 0, 0 table when I'm doing standard form for lines. And on the SAT, it works beautifully, like almost all the time. All right, number 28. The interstate route from Los Angeles, California to Jacksonville, Florida costs $5 billion total to build. So $5 billion total. And has a distance of 2,500 miles. So $5 billion is the cost, 2,500 miles of road. So I could divide those two and figure it out. Each mile costs $2 million. All right, so let's just see that. If it's $2 million per mile, and then I times that by 2,500 miles, well, let's just see how much that would be on my calculator here. So 2 with 6 zeros times 2,500, and there are 9 zeros there. So that checks out. That would be 5 billion. So if the linear relationship between the distance in thousands and the cost in billions, okay, what is the y-intercept? So let's think about if we graph this and we had cost and we had the number of miles. Well, the y-intercept is when x equals 0. When we have 0 miles, it's $0. We haven't fixed anything. So our chart would actually start right here. If you do 0 miles, it costs $0. This was a pretty stupid question. I think it was one of the worst worded questions so far on this test. But every test I find a lot of stupid questions, but still got to be able to answer them. So that one's 0, 0. Next question. See if we can get a better one here. So we have the same thing for 29 and 30. Population of Alaska and Hawaii from 1960 to 2015. We have those functions, A and H. X is the number of years since January 1st, 1960. So for instance, like if X equals 1, that would refer to 1961. If X equals 2, 1962, and so on and so forth. They just don't want to have to put those big old numbers in. So based on the model, what is the predicted population of Alaska on January 1st in 1960? So if you're at 1960, you want to put x equals 0 in. And we're talking about Alaska. So we're going to use this equation and we're going to put 0 in. The Alaska equation, when you input 0, is 221 plus 9.78 times 0, which is going to wipe itself out. So 221. That was pretty easy. Let's go to the next one. Same setup, different question. Based on the model above, what year does the predicted population of Hawaii exceed, that means bigger than, 900,000? All right. Well, one thing I noticed that you got to be careful on here is it says the population is in thousands already. So for 900,000, I'm just going to use the number 900. All right. So we're only using 900. So Hawaii is going to be 900 at what x? So basically we're just solving this for x because we got to figure out when it hits 900. So let's do that. We're going to take away the 645, take away the 645. You gone. This is going to be 255 equals 14.5x. Divide. And let's go to the old calculator. 255 divided by 14.5 is about 17.6, 17.58. So that's years, but that is after 1960. So we're talking like between 1977 and 1978. So I'm going to have to go with correct answer D before we go over that. All right, keep on going. Where are we at here? All right, free response, number 31. Let's go. In a system of equations above, k is a constant. If the system has no solutions. All right, so remember, no solution. When you graph this, no solution is going to be two lines that are parallel. They never cross. So they're going to have the same slope, but different y-intercepts. So basically, when I look at these two lines, I need this slope to match this slope. I need those x terms to be exactly the same. So one way to do it will be, well, when is 3/2 going to equal k over 3? I need those to be equal. So I could cross multiply to solve this. I get 2k equals 9. So k equals, you could either put 9/2 or 4.5. Either one of those would be acceptable. That would give me two lines with no solution. If they ever say infinite solution, if they want you to find infinite solutions, all right, well, that's a situation where it's a line right on top of itself. So these are not only going to have the same slope, but they're also going to have the same y-intercept. A little bit harder to make that happen, but these back numbers would have had to have matched if we were going to be infinite solutions. All right, number 32. Looks like we have a reading data chart here. Bar graph shows the number of discovered near-Earth asteroids as of April 17 of the near-Earth asteroids. How many more? All right, so be careful right there. That could trip people up. How many more? So that means I'm going to be doing some subtraction. Are classified as medium, large, or very large. So this is one group. Then are classified as very small or small. So it's like we have a blue group and a black group. So who's my blue group? Medium, large, or very large? So these three, this is my large group, and these two are my very small or small. And I want to know how much more the blue is minus the black. So I got to add these numbers together. So let's go ahead and let's just grab a calculator. Let's add these three up. Be careful here, because this is not multiple choice, so if I hit something wrong, I'm kind of screwed. Plus 876. So I'm getting 8739 for the blues. And then for the blacks, I have 2911 plus 4406. So I'm getting 73. Well, maybe I should color code this. 7317. So 8739 minus previous answer. I'm getting 1422. Like I say, just be really careful on that, because if it was multiple choice, at least I'd feel better if I'd seen it there. But that's why it's always nice to leave time to be able to go back and double check. All right, so this happened earlier in the test, and this again is a quadratic because the highest power is a 2. Normally I would try to factor on this problem. Problem is there's no two numbers that times together to make 9, add together to make 4. And I see this and I recognize this. That right there is a quadratic formula. And it basically wants me to solve it, and my answer is going to be in the quadratic formula. But then I need to figure out what m and k are and add those two together. So let's just go over quadratic formula really quick. Standard form is ax squared plus bx plus c. So in this equation, for mine, the coefficient in front of x squared, a is just 1, b is a -4, and c is a -9. Now, the quadratic formula in general is -b plus or minus the square root of b squared minus 4 times a times c all over 2a. And I'm sorry, man, you just got to memorize this. There's no two ways about it. It usually shows up once a test, so it's not like hugely important, but if you want the very best score possible, you got to memorize it. So let's jam some crap in here. So negative b. So that would be negative 4, which is just 4, plus or minus the square root of, well, b squared, negative 4 times negative 4 is 16, positive. Subtract 4 times a times c, all over 2 times a, 2 times 1. When I do that, I get 4 plus or minus, well, that's 16 plus 36, so that would be 52 all over 2. Well, notice what they want me to find. They want me to find, they have an m written right here and a k written inside there. So they want to know what is m plus k. Correct answer to this problem, 56. So not too bad. I've seen worse quadratic formula ones. Not too bad, as long as you understand what the m and the k, what they're actually looking for. All right, what is the result of increasing 300 by 200%? So a couple different ways to look at it. Let's make an easier problem. What if I wanted to increase 300 by 10%? All right. Well, I know that 10% of a number, I just move the decimal one to the left. So I know increasing 300 by 10% would mean increasing it by 30. So that would give me an answer of 330. All right. In general, when you want to increase it, if you take the starting amount and you multiply it by 1, you don't increase it. It stays the same. But if I want to increase it by 10%, I would increase it by 0.10. So on this one, I want to increase by 200%. I'm going to do 300. I always got to do 1 plus. Well, my percentage here is 2.0. All right, so that's really, I'm really tripling it. It's actually 900. All right, and it kind of doesn't make sense. They probably want you to put 600, but when you increase by 100%, you double. All right, so that's just kind of a good thing to remember. If you increase by 100%, that's a double. If you increase by 200%, that's a triple. And you're always kind of one behind where you think you should be. So I could see where that one could trip some people up. The math wasn't too bad, though. This one looks kind of gnarly. Two numbers, a and b, are each greater than 0, so we're talking about positive numbers here. The square root of a, so let's write an equation here. The square root of a equals the cube root of b. And then it says, for what value of x is a to the 2x minus 1? So this is kind of like a little side thing. A to the 2x minus 1 equals b. Well, I think we're going to need to use some sort of fraction exponents. So this is kind of a rule that you need to know is like the square root of a can be written as, that could be written as a to the 1/2. And the reason being is it's really the square root, and that's really a to the 1st. So there's kind of a rule where you can just put the inside on top and the outside number on the bottom. So if I do that same thing with the b's here, if I do the inside on top and the outside on the bottom, I now know that a to the 1/2 is the same as b to the 1/3. I'm going to try to figure out what b is and substitute it. So for instance, to change this over here into b, I'm going to raise that to the 3rd power. Because whenever you take a power and you raise it to a power, you multiply. That's really like b to the 1/3 times 3, which is b to the 1st. So this side's just b. But if I raise that side to the 3rd power, I have to raise this side to the 3rd power. And that's a to the 1/2 times 3, or a to the 3/2. Well, now I know what b is. B is this thing. So I can come over here and I can substitute and get rid of that b. And I can go a to the 3/2 And now to solve this, I have the same base. I have a to the something equals a to the something. So these two somethings have to be equal to each other. So when is 2x minus 1 equal to 3 halves? Or maybe I even want to do 1.5. There's nothing that says I have to do fractions, so it's a nice decimal. So when is 2x equal to 2.5? Divide both sides by 2. And I get 1.25. If I would have left that 3 halves, it would have came out to be, add another 2 halves, 5 halves. So it ended up being 5 quarters if you would have left it as a fraction. All right. Now, sometimes you can sidestep these problems. So if I lost you during that, let me just give you another way to just be a problem solver and just to kind of get after this. All right. So think about perfect squares. You know, perfect squares are numbers that have nice square roots, like the square root of 4, the square root of 9, the square root of 16, the square root of 25, square root of 36, so on and so forth. All right, I'm not going to go any more. You know, and this equals 2, this equals 3, 4, 5, 6, 7. Those are worth knowing. You know, perfect cubes, well, those are kind of worth knowing too, because the cube root of 8 will also give me 2. Another one would be, another perfect cube is like the cube root of 27. Well, that's 3. 3 times 3 times 3 is 27. You know, 4 times 4 times 4 would be 64. 5 times 5 times 5 would be 125. So it's kind of worth knowing some of these perfect cubes and the perfect squares, because really what this was asking, it said, hey, the square root of some number is the same answer as the cube root of another. And that was right here. The square root of one number equaled the cube root of another. So I knew that my A was 4 and my B was 8. So I could have maybe snuck this problem and said 4 to the 2x minus 1 equals 8. And then I would have had to do some work. It would have been messy. I could have wrote them both as powers of 2 and been like 2 squared to the 2x minus 1. And this is equals 2 cubed. And so multiplying my exponents, 2 to the 4x minus 1 equals 2 to the third. I guess I would have done the same thing, trying to solve when is 4x minus 1 equal to 3. So 4x equals 4. Now what did I do wrong there? Oh, I didn't distribute. That's 4x minus 2. Minus 2. So 4x would equal 5. And I would get x equals 5/4. So I could have went that route. I guess it was probably easier the way I did it with the fraction exponents. But nevertheless, hard problem. One of the tougher ones on here. All right, let's shrink this baby down a little bit. We can see what's going on. So this is a twofer. Get to knock out 2 for 1 here. So the graph above shows total number of scheduled flights and then delayed flights for 5 different airlines. According to the graph, what is the middle number of delayed flights for the airline shown? Where delayed flights are in the black box here. They're the black boxes. So we're talking about, you know, right there, right here, here. Well, the middle of all those, you know, you're the biggest. And no, you're the biggest. You're the second biggest. I would say that you are third. And then you're the smallest and you're the smallest. So that would be the third biggest one. So that would be D, which when you come over here, it looks like it's going up by every 5,000. So 5,000 is the median. You know, another way, if you really wanted to write those out, I could have just listed them out And, you know, this one looks like 7,500. This one is 15,000. This one is, I don't know, 2,500 maybe, 5,000. And this one's maybe also 2,500. So when you list those out from smallest to biggest, you know, a smallest, a biggest, a smallest, and this was supposed to be 15,000, a biggest, and you would be the middle number left over. 37, according to the graph, for the airline with the greatest number of delayed flights. So we're only looking at the airline with the greatest number of delayed flights. So right here, so for the airline with the greatest number of delayed flights, what fraction of the total, so of is the bottom, of the total number of scheduled flights? Well, scheduled flights is the gray. So scheduled flights is 40,000. Were delayed flights. Delayed were 15,000. So there's my fraction. If right off the bat, if I divide by 1,000, you know, those are gone. So I'm looking at 15 over 40. On the SAT, though, remember there's only 4 slots, and this slash takes up one of them. So you would run out of room because you'd have 4 numbers in a slash, so that'd be 5 spots. So you're going to have to reduce this. 5 goes in here 3 times. 5 goes in here 8 times. So when you bubble that in, you'd bubble in 3/8. So 3/8. All right, final question. See what we got here. Number 38, the expression 0.6y represents the result of decreasing a quantity y by p%. All right, so I want to decrease y by p%. All right, so that means I'm starting with some number y. I'm multiplying by 1 does nothing. Decreasing it means I'm decreasing it by this p% here. And somehow I end up with, it wants to know what's the value of p, so they want to know what's the percentage, by how much percent. Well, if I start with y, and I end up with a 0.6y, that means we took away 0.4. All right? Because 1 minus 0.4 will give me 0.6. But 0.4 is a percentage. 0.4 is really 40%. Because when you move the decimal 2 places. So by what percent? Correct answer here is 40.